Welcome back everyone to Data Science for Everyone. Today we're going to be talking about random forest utilizing the loan dataset. Let's get started. Okay, so we're going to go over the random forest and loan data set. I'm going to actually kind of skip over discussion of the data set itself, because when we're going through everything we'll be looking at it. So let's go in and import our standard libraries. So import pandas as PD, import numpy as MP, import seaborn as SNS, import matplotlib.pyplot as PLT, and then let's make sure to do matplotlib inline. Now let's make sure and get the data. So I'm just going to say, I'll just do df, and then let's do pd.read csv here, and then we'll do loan data.csv. Let's take a look at the head of the data. Whoops. Take a look at the head of the data to see everything. Okay. All of this looks good. I personally don't like having these periods in there, so I'm going to go on and change that as well. And then also, let's see if I want to do anything else. Let's also do df.columns. Check. Yeah, okay. I don't see any white space in there, so we'll go on and do something like c.stir.replace. And we want to replace periods with underscores for C in our data frames. Oops. That's here for C in data frame columns. And let's take a look at it before we assign it. Yeah, so let's just do replace because it's actually it's not a data frame. There we go. Okay, so now we see here that it actually removed all of the periods from there, and we have our underscores. So let's go on and put that in and overwrite. So now we have things that look a little bit cleaner. So now let's look at the information of the data set. So we see here that we have our credit policy, we have no missing data, purpose, interest rates, installments, log annual income, DTI is debt to income ratio of the borrower. So there's the amount of debt divided by the annual income. We have their FICO score. We have days with the credit line, and this is an incremental number of days for the credit line. We have the revolving balance and the revolving utility or utilization rate on each of those, and then we have here the borrower's number of inquiries by the creditor for the last 6 months. We also have the number of times a borrower has been 30 days past due, and then the borrower's number of derogatory public records, so bankruptcy filings, tax liens, or any types of judgments. And I think we'll probably not deal with this one not paid in full here is just things that they haven't paid in full. And again, that's an integer. So, and then what do we have here? We have one object, and that's the purpose. And so we can take a look at this just, again, really quickly. Let's look at the description. Describe, and I want to tab that over, and let's take a look. So we see here that everything looks okay. They are not in the same magnitude whatsoever on these, but that's okay. Let's also take a look at the head of the data and see what's going on here. So again, here, the purpose, they have debt consolidation, credit. So let's also take a look and see what that purpose is. Unique, whoops, I actually want the purpose. So let's take a look at what unique values it has. Debt consolidation, credit card, all other, home improvement, small business, major purchase, educational. So you can see basically the purpose or why they actually wanted that loan. So let's see what else what we like to do here. So let's do a little bit of a exploratory data analysis really quickly. So we want to do something like PLT figure, and let's make sure that this is significantly big. We want fig size, and let's say that it's 12 by 6. And then let's do something like we want to look at the credit policies. Let's take a look at the credit policies. What are the credit policies, and what do they kind of look like here? So let's do policy.unique. Okay, and so it's a binary here. And so for the credit policy is 1 if the consumer meets the credit underwriting criteria of the lending club, and a 0 otherwise. So we want to take a look at both of these, particularly when it comes to maybe doing let's do a histogram of each of them. So let's do this with just the basic hist. Loans, we want not loans. I used what here? df dot, and we want here where the credit policy is equal to 1. And then we want to grab the FICO score from that individual dot hist. And then let's do something like alpha is equal to 0.5. We want the color. Well, let's just leave the color as a default. Bins, let's do 30. And then a label here is credit policy is equal to 1. Let's run this really quickly. Okay, so that's fine. I want to do, let's do another one, and we'll do them actually together. And let's look at, this is to 0. Run those together. All right, so this is with our 2 FICO scores based on their credit policies. So this particular graph can be a little bit tricky here, but again, just knowing that you can run the 2 histograms simultaneously is okay. We can also do this with Seaborn as well, but I thought that this one actually looks pretty decent this way. And so let's also create another one here. And so I'm actually going to just copy this and put it down here. And what do we want to do here? Let's do this for not fully paid, okay, instead of the credit policy. So not fully paid here, and let's change this to not fully paid. And oops, and you know what? I messed up here. This needs to be 0. There. Okay. And this we can change as well. So it's not fully paid here, and then this one is going to be not fully paid as well, and then this one is going to be 0. I take a look. All right, and you can see here that the definitely the not fully paid is 0 is going to be much larger, so people wound up did actually paying in full a majority of the time. We do have areas where there's big jumps here for how much they are in both instances, and probably the reasoning behind that is probably these are good round numbers when people are getting loans. So let's also do oh, you know what? I actually forgot something in here. That's why it's not looking right for you guys. So we also do want to do plt.legend in here so that we can actually see the legends. So see there, now we actually get our policy count stuff in there. And let's put this one plt.legend. Okay, and now we actually have our legend in there. And you know what, let's actually add in another one, plt.xlabel, and let's call this the FICO. So then they actually look right. for us. Okay, now they have nice a little FICO down there. Grab this as well. Put this down here so that they actually look properly labeled. Okay, so next let's take a look at doing some count plots. Again, we see here that they're not actually normal distributions whatsoever. They're flat, and this one actually has a tail. But so then let's also look at the distributions, because again, when we're doing some sort of classification analysis or anything, we need to make sure that our data itself is probably equally distributed, particularly if we do our train test splits correctly. So let's do this 12 by 6 as well. So let's just do a count plot. X is going to be the purpose. Y here is, we don't need a Y because we're doing a count plot, but let's do hue here as a not fully paid. And then we want our data is equal to our DF. All right, and so then here we definitely see that so people that are fully paid are considerably in the majority. So we do have a relatively unbalanced data set. So depending on this type, we may want to look at doing our train test splits on a stratified train test split if we need to. But let's also look at maybe this relationship between the FICO score and the interest rate. So let's do a joint plot with that. X is going to be FICO. Y, let's make this the interest rate. Data is DF. And let's take a look. What didn't it like? Oh, joint plot, not joint plot. And so we can see that there's definitely a negative relationship between interest rate and the FICO score. So as interest rates go up, the FICO score is definitely going to go down. And part of the reason is the higher interest rates, it's going to be more difficult for people to pay off. This is a little bit difficult to see because it is so dense. We may want to look at maybe a hex plot or something else. Maybe we can take a look at that really quickly. Kind is hex. Take a look, actually. I still want this. To see, and we can see the density here a little bit better. We can see here that, again, a majority of people have something around, somewhere around a 670 to maybe a 720 or something. And then we have some people that are right below that. We have a little bit of a passage here. Maybe we can change this to a KDE. And take a look as well. All right, there it is. So yeah, we definitely have these kind of high density impacts in these two separate areas in there that we can see. So again, it just depends on what you want to look at when you're looking at the data, but it is nice to know that there are these two kind of clusters and groupings, particularly when we're starting to discuss how the analysis will actually play out. So let's also look at some linear model plots to see how everything should be going. I want to make this bigger. Fig size here. What do we want? We want this 12 by 6 again. And let's do SNS.lm plot. Y is equal to our interest rate. X is equal to our FICO. Date is DF. Hue, let's do this by the credit policy. And let's have our column be by not fully paid here. I think that'll be fine. That is ugly. But it's still okay. I wonder if we can change this just a little bit more here so that's cleaner. What would we want to do with this? well, here this one doesn't have alpha. Let me see if there's something we can do on it. If not, we'll move, you know what? Let's not waste time on it. We'll move on because we still need to go through the rest of everything. So, but what we see here is that there is still, no matter what, whether it's full, if it's paid in full, or whether it's not paid in, whether it's paid in full, there's still a negative relationship between the FICO score and the interest rate. That may not be as steep, okay, between, because again, you can see from the trend lines here, it may not necessarily be as steep, particularly when it is talking about credit policy 0. And credit policy 0, so 0 here is they did not meet the credit underwriting score, okay, and then they did pay in full. So let's see, what else do we want to deal with here? Okay, so the next up, all right, because again, the features that we've been looking at here is this not paid in full, and we've also been looking at, for example, like this purpose data as well. We need to take care of our categorical data, our categorical features. And our categorical features, let's look at df.info here. Now again, some of these zeros and ones can also, again, this is, regardless of whether this is numeric or not, this is technically a categorical. But the one that we really want to look at is this purpose, because again, it is an object. Okay, so we need to do some transformations for the dummy variables so that Sklearn can actually understand them. We also, let me see here. What else do we want on here? So we need to also make sure and kind of let's add in a staging area here for our categorical data. So we want our cat feature, categorical features here, and it's technically just going to be purpose. All right, if we had multiple, we could put in multiple in here, but the one that we have to watch out for, because it is an object, is the purpose one. Otherwise, everything else is technically already in a dummy variable format, being where's it at? So like this interest paid in full is an integer, and it's still binomial, it's a 1 or a 0, so it will still work otherwise. So if we do, we'll just call this df final. Here we do pd.get dummies here, and we do this on our data frame, and the columns that we want in here is our cat features, and then we do drop first is equal to true, so that we're removing that excess data. So now let's also look at our df final.info in here, and now we see that we have all of these purpose data in here, and this is these are now a dummy variables, and we wound up dropping the first one, which was what? Let's do value counts on it. Was what, debt consolidation? No. It dropped all other from the purpose. Okay, so it dropped this one. So now let's also make sure that we do our train test split. We're going to do a normal train test split on this model. So let's put in a note here. All right, train test split. So from sklearn dot, learn.model selection import train test split. Import train test split, and then we will grab our template from here. Run, whoops, not X and Y, Let's set up the x and y's though. Let's set up x and y's here. So x is going to be our df final here, and we want to drop whether they are not fully paid, because that's what we're going to want to predict from access is equal to 1. And again, so here basically what you're saying is that whether they default on their loan or not. And so that's actually very useful for banking industry, or even again if you're doing small time loans. And again, this one's from, I believe, Lending Tree or something. So let's do df final, and then we want here not fully paid as our x and our y's. All right, so now we've created our train test split. So let's go on and take a look at our decision tree. Our decision tree model. So from sklearn dot tree import decision tree classifier. Come on now. Decision tree classifier. Our tree is going to be a, and you know what? Let me put a C in there for classifier. And then let's fit the data. Dot fit here, and we want our x train, our y train, and we'll leave all of the standard notation. What didn't it? Oh, fix it's fit. And we'll leave all of the standard everything in here. We don't have to really go through and optimize anything yet. And after this, we will do the random forest as well. So let's do our predictions and evaluation of the decision tree. So we have our prediction algorithm and the dtc.predict here, and we're doing this on our x test. And then from sklearn metrics import classification report, and we want our confusion matrix. So let's print, whoops, what didn't it like here?
Missing the I in classification.
Okay. Thank you. Classification. Okay. Fingers are not working at their best today. So then let's do classification report here. We have our y test with our predictions. And we are doing not great. Again, our accuracy is around 74% here, but our macro average here is 53 and our weighted average is 75. I would give this a, again, just as what this score here says, is we're at about a C range. It's not perfect. Now let's take a look at our confusion matrix. Y test with our predictions, and let's see how we're doing. And again, we're okay, but again, remember this, one thing that we would probably still want to do, and something that you guys can do to practice, is try and do a stratified split, because they are unbalanced classes. And I'll probably make a video or do a class or something on unbalanced classes in the next week or so. I think that would probably help you guys out, because we are able to overcome this, even with some resampling. So let's go on though and do the random forest model. And so from sklearn.ensemble methods, we want random forest classifier. Random forest classifier is going to be our random forest classifier instantiated, and we want our in estimators. Let's do 600. So rfc.fit here, we want our x train, y train here, and then we're going to also do our prediction and our evaluation here. And again, we're going to keep all of the standard attributes in there for now. So let's look at, we want to print here our classification report. And we want our Y test with our predictions. Oops, and I didn't do any predictions. Let me actually do the predictions. So we want our predictions. Predictions here is RFC dot predict here, and we want it to be on our X test. All right, so we ran this, and now this is doing a little bit better. Okay, we're at a kind of a B range. Our macro is actually doing okay. Our average weight is actually doing okay as well. Recall is doing even better than before. So then let's also double check on our confusion matrix. Check that as well. And this is doing considerably worse, actually. Okay, so if you looked at what we had before, we actually had more predictions going on. So that's one thing that we need to actually look at. Okay, so when we talk about which one actually did well, actually in this instance our decision tree actually did a little bit better because of one thing, is it actually took care of some of these issues in here. But if we look here at our decision, our random forest actually wound up, when we look at our data, it's actually wound up just kind of throwing a lot more information inside of here and taking in more error over here and here as well. So this is something that, again, this is kind of a double-edged sword when you're wanting to compare them. I would highly suggest that we go back and maybe do a stratified train test split with this data and also probably go back through and do some other types of resampling techniques that deal with unbalanced classes. And so that maybe I'll write this as a note for next time, is unbalanced classes. Thank you guys so much for watching. If you like this, please comment, subscribe, and hit that like button. I'll see you guys next time. Bye-bye.